Let's deal with the next topic, which is looking at how energy moves around in an ecosystem. Specifically, we're going to talk about the nutrient cycle, food webs, and of course, smaller food chains. There are different categories of living things in an ecosystem, and the first is those that make their own food. The fancy term for that is autotrophs. So groups of organisms that can use the energy from the sun and carbon dioxide to make food. Autotrophs are often called producers because they produce all the food that the heterotrophs, which we'll deal with later. Without autotrophs, there would be no life on Earth, and examples of autotrophs or producers are plants and algae. Let's deal with the second group. These are called heterotrophs. A heterotroph is an organism that doesn't make their own food. And another term for this is consumer, because they consume other organisms. Examples, rabbits, deer, mushrooms. So herbivores are animals that consume just plants. So an elephant just eats plants, horses, grasshoppers. However, omnivores are animals that consume other animals or plants. A raccoon is an omnivore, a bear is an omnivore. And of course, a last type of heterotroph is a carnivore, and these are animals that consume mainly just other animals. This is a pitcher plant. Believe it or not, it is sometimes an autotroph, but sometimes it's a heterotroph, which means it eats flies. Flies come in there. And the Venus flytrap, same thing. Normally it's a plant, but sometimes if it doesn't get enough nutrients from the soil, it has to consume others. Here's some more examples of heterotrophs. Scavengers are special kinds of heterotrophs that feed on dead organisms, so vultures, crows, and sometimes shrimp. Herbivores eat only plants, cows, elephants, giraffes, and carnivores eat only meat, sharks, lions, tigers. And omnivores, we're omnivores, bears are omnivores. Decomposers absorb only dead material, so bacteria and mushrooms are good examples of decomposers. Let's talk about scavengers, because lots of people think that a scavenger is a decomposer, and that's not necessarily the case. Basically, all a scavenger is a lazy consumer. So they don't hunt or kill their food, they wait for it to die. Vultures are a good example. Whereas a decomposer has a little bit more benefit because it consumes and breaks down the dead organisms and puts that material back into the soil. So scavengers are different. They're simply just a lazy consumer, whereas a decomposer will break down, they'll chemically break down the dead plant and animal waste and put it back into the soil. Let's talk about how energy transfers. So a zebra eats the grass. It does not obtain all the energy. Where does some of the energy go? Or when a lion eats a zebra, it doesn't get all the energy from the zebra because lots of it is lost due to heat. So energy moves from one organism to another when it's eaten. Each step in this transfer is known as a feeding or a trophic level. The main trophic levels are producers, consumers, and decomposers. So we use food chains to represent or draw that energy flow. A food chain is very simple and direct. It involves one organism passing energy on to another. And so here's an example of a food chain. Food chain always begins with the sun if it's available, and then the first person or first thing that's linked to the food chain is the autotroph or the producer. And then let's say a grasshopper eats the grass. We draw an arrow to the grasshopper to represent the flow of energy. And then maybe a snake eats the grasshopper, and we would put an arrow to the snake. And then maybe a hawk And then if there's a decomposer, we would draw it last, and then it goes back to the producer because decomposers put nutrients back in the soil. So it's a cycle. It's a nutrient cycle. Notice some of these terms. The herbivore is called the primary consumer, and then the next carnivore is secondary, and then the next carnivore would be tertiary, and so on. So that's a food chain, the flow of energy. Don't forget, energy is lost along the way. So lost due to what? Due to heat. So the closer you are to the sun, the more energy you get from the sun because energy is lost due to heat along the way. And then a food web is just most organisms will eat more than one type of organism. And so a food web's more intricate. Food webs are complex and they involve lots of organisms and many food chains combined. And we should be able to analyze food webs to see how many different herbivores are in there or carnivores, etc. Notice that the direction of the arrow points to the direction that the energy is transferring. So here's another food web. Lots of arrows in different directions. Let's talk about biomass. Biomass is the total mass of organic matter. Biomass is just another way for the amount of energy that might be there to eat. And so if we look at this picture, remember the closer you are to the sun, the greater energy that's available. It's like being closer to the power source. So as you move along, what do you notice about the amount of biomass? It goes down the further away you are from the sun. And so we sometimes use food pyramids to draw what this energy potential looks like. So producers are here because they get energy directly from the sun and they're at the bottom of our pyramid. And then primary consumers are next, then secondary and tertiary are on the top. Again, smaller energy at the top because you're farther away from the sun and more energy is lost due to heat. Here's another food pyramid. Again, producers go here, primary consumers are herbivores, secondary consumers, and then carnivores or tertiary consumers. And you'll notice it's in the shape of a pyramid because as you go higher up the food chain, less energy is available. So, which energy has the most? This one. Which has the most organisms? The bottom one. And which has the least organisms? The top one. Here's another food chain. So we would have the sun here, and then grass is our autotroph or producer, and then an aphid eats the grass. We draw an arrow. Spider eats the aphid. Bluebird eats the spider, and then fox eats the bluebird. Food chain. How about a food web? This one's a little more complicated. Can you identify all the primary consumers or herbivores? Here's one, because it eats the plant. Here's two, the caterpillar eats the plant. Here's three. Here's four. And five. There are 5 herbivores in this food chain. Let's finish by watching this video clip on food chains.
A nuclear reaction happens deep inside the sun, where hydrogen atoms are fused into helium. Then their heat and light is radiated into space, and 90 million miles it shines upon the Earth's face. For every 100 calories that shines up from the sun, the calories are green, plus triple number only one. But every single calorie in ocean, hills, and plains will serve as a foundation for a living food chain. At the bottom of the food chain are producers like in plants. The cells make food from sunlight, making use of chloroplast. It happens in the pines and flowers on your windowsill, 'cause every single green one's got a little chlorophyll. Well, the next bit of food chain is a primary consumer, an herbivore, a cow, or vegetarian baby boomer. The primary consumer spends its mealtime eating plants. Might be a buffalo or might be an ant. Each level in a food chain yields only 10%. Of the former level's energy, you might as well there are bones and leaves you can't digest to really make a dent. And don't ignore the weight and cost of metabolic rent. So if your plants are yielding about 100 calories, your yield will only be 10 in the birdies and the bees. 700 calories in algae in the sea. Primary consumers, it will yield you 17. Some other ways of getting food are really out of sight. You can be a predator or be a parasite. Predator eats meat, a parasite eats your insides, and if you're a decomposer, you will leave me when I die. And if you know this about food chains, you can really take the cake. When energy goes through, it doesn't last, it dissipates. Nutrients and food chains meet a very different fate. They recycle and they circulate forever, ain't that great? Just remember there's no beings in this world that live alone. Populations form communities where all to make their home. Though your niche may be determining the role that you are playing, every creature alive or dead is in the food chain.